Hello, in this video I'm going to be talking about how to implement audio into VR using Wwise and Unreal. Alright, so the first thing I wanted to do was to add a sound as the projectile left the pistol, so I went over to the VR pawn, and these are all the default nodes that the VR template comes built with. So I looked over in trigger pressed on the input action trigger left and right, and on both of these, both the left and right, I posted the event that triggered the shoot sound, which is in this case called shoot, tied it to itself as the actor, and you can take a look at it over here in Wwise. It's hit sound and shoot, and we can give it a listen here. And of course that's in our actor mixer hierarchy over here under weapons and shoot. There's only one sound. And so the next step was for me to trigger a different sound upon hitting a different surface with that projectile. So to do this on these particular static meshes or blocks, I decided to go with the line tracer method, which means that I basically have a laser pointer, and whatever it's pointing at, it detects what kind of surface that is. And to do this, went into project settings, went over to engine and physics, and I wrote in these surface types. So you can see water, wood, and metal here. And upon doing that, I created these physical materials, which you can see under the menu here. And you can see metal, water, and wood. And in these physical materials, I just put in the surface types. So after doing that, I just decided to take the static mesh and change the material element, which is, in this case, I made it gold. And in this material, I added the physical material and plugged in the respective physical material. So the next step was to actually make the line tracer. So we'll go into our pistol, since that's where we're shooting from. And over here we can take a look at all these default nodes that were created in this template. But this is just basically where the muzzle is, where to spawn that projectile from, and to play the haptic feedback. So what we did over here is on the trigger pressed, we got the world location of the muzzle, and also the world rotation, so how it's moving, and the forward vector. And then we multiplied that by 1500. Since it doesn't shoot super far, we added that with the world location and created an endpoint. So that's where the line trace actually ends. So that's where we can kind of see what surface we're hitting. And from the start point, that's the muzzle location. So that's where the line trace begins, and we execute it over to the spawn active projectile, where we actually spawn that projectile. Over here I created a branch because I was experimenting with things that had a tag, but I won't get into that since what we're hitting right now does not have a tag. We go down to the get AK component. You can see that's routed over to the projectile hit, where we then set the switch. That's where all our materials that we looked at earlier come into play. So if we look at our physical materials hit over here, we get the display name and plug that into the switch state. And then you can look at our switch group over here, which we could take a look at in Wwise. Game syncs, projectile hit, you can see metal, water, wood, and these are the switch groups I added. And here in our projectile hit, we can see the sounds that are played as well, assigned to the appropriate objects. So back in Unreal, after that, all we did was post the event, which is tied to that switch container. So after that, we just play the haptic feedback, and that's it. One thing I wanted to talk about was that I noticed when casting, the line tracer is not actually aligned, even though when you do wear the headset, the line tracer is aligned. So I wanted to demonstrate real quick that it is actually aligned, even though the casting session does not show so. So what I did was shoot the edge of the box, and you can see that it still detects the correct sound. So you can see that it's not aligned there, but it's still detecting the correct material, which in turn is changing it to the right switch. So another thing I wanted to do was to trigger audio upon hitting some of these other objects, and some of these were small cubes, and another is this black sphere we have over here. So on these small cubes, this is much more straightforward. I just added a blueprint to it. So again, there's nothing here. I added a box collision or box collider. On component begin overlap, I dragged that in from the box collider and just posted the event. In this case, it was called small cubes, and actor is itself. And over here, if we look at the event, we can see small cubes, and it's tied to the sound random container of meow, which is over here. I had to keep myself amused in doing this, so I just got a bunch of samples of cats meowing. So yeah, I just did that in a random container, and we can see how it sounds over here when I play the event small cubes. And sure enough, in game, once you shoot those cubes, it'll trigger them, as I'll show you right now. So I set the projectiles to not bounce, so once they hit a surface, they kind of just disappear, and I thought it'd be kind of cool to make something, kind of make it look like they're kind of sucking in the projectiles and making them kind of just disappear. So I created this black sphere, and in this I added a sphere collider, and I made the static mesh black color. And then again, same thing, just begin overlap, very similar to what we did with the cubes. And this AK event was called Vortex 2. And here we go with Vortex 2. And we can kind of see how that's tied over here to the Vortex audio. Alright, so this is where it gets a little bit more interesting. So if we look over the sphere, I wanted the audio to change according to how fast this ball is rolling. So in order to do so, I had to create an RTPC and tie it to the value of how fast this was rolling. So I made a blueprint for this, and we can take a look at over here. We'll start with the set RTPC. And if we look at this, I set off in an event tick, which triggers something every frame, and just simply got the AK component of that ball over here and set the value, which you can see here. The RTPC name is ball, and this is tied to this value which we calculated over here. So the static mesh component, and we got the angular velocity and radians of the component, so how fast the ball is rolling. Broke that into a vector and made it into something easy so we could get a return value for it. Got the vector length, and I just made this an absolute value just in case it was rolling around and we got negative values. So put that in, and that's how we got our RTPC value. Now if you look here, I had this originally tied to the print string so I could see the values written on the screen, and that is how I got this range over here. If we look at our actual RTPC and Wise, we can see that our range is 0 to 20, and that was basically how fast the ball is rolling in the game. And over here, we can take a look at our ball, and you can see here that our RTPC is tied to voice pitch and voice volume, so I'm going to go ahead and show you how it sounds in Wise. So If we look back in Unreal, we can see that I added a wake sleep component, so whenever the ball is moving, it actually triggers the event that plays that ball sound, which is really just a sound that is looping infinitely, so it sounds like this. And when the RTPC moves around, we switch, the audio changes. So if we look at this, I also added a couple of damping values in order to get more variation, because originally the ball was kind of moving at a steady pace and it didn't slow down really. So this kind of allowed it to slow down and in turn change those values a bit more and change the audio a bit more. So in case you didn't notice, we have a big door here which leads us into another room with a bunch of other features that I'm going to show you. But before we get to that, I'm just going to show you my thought process behind this door. So the idea was to hit this button over here, which will then trigger this door to open. So instead of having these be separate entities, I just actually wanted to have the collider. You can see this box collider is actually just moved over here, so whenever anything goes in contact with that, it'll just trigger the door opening function. And here you can see the on component begin overlap event that triggers, and we can see that it's a do once node that plugs into actually the event that is called in Wwise, and then here is just the open and close function, and you can see that I delayed it for 5 seconds, so it'll stay open for 5 seconds, and then it'll close, and then once again it'll call the same event in Wwise. And the reason why it's called on the same event instead of a different close sound is because it's in a sequence container. So if we take a look at this, I have a door open and close on this playlist over here. So once we hit the door open, and again, it'll just move on to the door close. So that's kind of cool. The button is actually just a separate blueprint component, so that it's not actually attached to the door, but it just triggers the button sound. So I have 2 button sounds in a sequence container that sound like this. Over here we can see that it says randomized notes, so this is basically just a C scale, but I just put them, these are all actually the same function. So these little pads over here actually, they generate the same event over here, which is, I'll go ahead and show you that in Wwise. Music sounds, and we can see the mid wall is what I called it. And we can take a look over here at music sounds. Oops, sorry, that's the bus. We could take a look over here at block notes. There we go, that's where I put it. And over here is a randomized container containing these notes. And basically the idea was to kind of be able to improvise music over a chord. And this middle one, if you look closely, I wrote, you can't really see it over here, but I wrote a 1 in Roman numerals, which is the 1 chord, and these are all the same, so anytime you hit these, it'll just play a random note off the C scale. And if you look over here, this is a 2 chord, so once we hit this, it'll change to a 2 chord, and then if we hit this over here, this is a 5 chord. So we can kind of solo over it and just improvise over it, if you will. So if we play a 2 chord, we can actually go over to this wall, and this will be a melodic minor of that 2 chord. So still kind of figuring out the right order to do, but in these blueprints, this is the kind of light up functions over here, so we won't pay attention to that really. So we'll look over here, and I actually made an event for each note on this scale. So that's a little bit more time consuming than I wanted it to be, but I think that was probably the only way to kind of really do that. Over here we have on this wall we have the altered scale. That comes from the 5 chord, and we can kind of play these kind of more obscure notes, as well as, you know, play these randomized notes. And when we're all done with that, we can hit the middle one to play the C again or turn it off. So again, I just wanted to apologize for that latency. I will definitely fix that in future videos. If I wanted to look over here again at these. So if we look here, we can see that this actually, so we have this sequence where it lights everything up and makes it glow. And then over here, I have a flip-flop node, which will either set the state to, you know, play whatever chord it needs to be at, or set the state value to none. And so each time we hit it, if we hit it once, it'll set the state to C major. And if we hit it again, it'll set it to none. And I actually routed this over to an actor, AK actor over here. So that's where the sound's coming from. And if you look into this actor, we can see that there's an event tick setting up every frame to play once. And it'll trigger that event, which is called in Wwise. And then if it is not playing, then we can see that it'll reset and repeat itself. So then I did this for this 2 chord as well, and as well as the 5 chord. So this is basically setting the switch again, just like we did, except it'll be setting it to a D minor chord, and it'll send it to this AK actor over here, and same with the 5 chord. It'll be doing the same thing. So these are basically just setting the switches, and this is actually playing the event. And over here we have these randomized notes once again, and a couple of things I wanted to talk about are in Wwise. So one thing that was happening was when I was playing the randomized notes with the chords is that it was clipping and it was being a little too loud. So what I wanted to do was add another RTPC called chords playing and sidechain that, so it kind of compresses the audio in, so while the chords are playing, I wanted to compress the audio of the notes. So I sent the notes to this music sound auxiliary, and if we look here, we'll see that the bus volume is connected to that chords playing RTPC. So as the chords are playing, we can hear the volume of the notes decrease. so that it doesn't clip or cause too much kind of noise crowding. That is about it. After that, we could just hit the button, exit the room, and call it a day. All right, thank you for watching, everybody. Thanks. Bye.